the image describes Kirlian photography, a fascinating technique used to capture images of an object's electrical discharge, or coronal discharge. Here's a breakdown. How it works. An object is placed on photographic film atop a metal plate. A high voltage current is run through the plate, creating a coronal discharge, a visible glow around the object caused by electrical ionization in the surrounding air. This glow is captured on the photographic film. History. Discovered in 1939 by Semyon and Valentina Kirlian, who noticed a visible glow around a patient during high-frequency electrical treatments in a hospital in Russia. Unique characteristics. No camera required. It's a contact print process, meaning it doesn't use a traditional camera or lens. A transparent electrode can also be used for digital capturing. The resulting images often show patterns of light around the object, resembling a halo or energy field. What determines the image? The pattern depends on the object's electrical. Since this involves high voltage electricity, precautions must be taken to avoid shocks, especially when working with conductive materials. While some associate Kirlian photography with metaphysical or spiritual interpretations, like capturing an aura, scientifically, the images result from the electrical properties of the object and its environment. Would you like to know more about its applications, or how to experiment with this technique?
So, can you explain what you mean when it shows the electrical properties, and what does it mean when the light is shown by the ionization?
Certainly. When Kirlian photography captures the light around an object, it's all about electrical discharge and ionization. Electrical properties. Each object has certain electrical conductivity, meaning it can either allow or resist the flow of electricity. For example, conductive objects, like metals, allow electricity to pass through easily, so they will produce a more pronounced glow. Insulating objects, like rubber, resist electrical flow, and thus, the discharge pattern may appear weaker or different. When a high voltage current passes through the metal plate beneath the object in Kirlian photography, it creates a high-frequency electrical field. This electrical energy interacts with the object, creating the coronal discharge, the glowing ionized light seen in the resulting image. TASH, ionization and the light. The ionization part is key. Ionization happens when high-voltage electricity causes molecules in the surrounding air to lose or gain electrons, turning them into ions, charged particles. The high-energy current makes the air around the object's edges ionized, and this process emits light in the form of a glow. The light pattern you see is essentially a visual representation of the electrical discharge occurring in the surrounding ionized air.
So, if it's possible for molecules in the air to be converted into ions, then would it be possible to use that ion as a battery to harness that charge? Because is an ion not basically a battery if it's a molecule that is holding a specific charge?
That's a fascinating question. You're absolutely right that ions themselves carry an electrical charge, and in a sense, they could be considered to hold energy in the form of that charge. However, using ions in the air from a Kirlian photograph or any other ionization process as a battery would face several challenges. Let me explain. Ion as a battery.
Why does it seem that cacao seems to have a very large energetic field in terms of this photography?
Great observation. The Kirlian photography technique can show very distinct patterns around certain objects, and you've noticed that cacao, or cocoa, seems to exhibit a large energetic field in such images. This can be tied to a few factors related to the material properties and the way energy flows through objects. Why cacao could show a strong energetic field in Kirlian photography. 1. High water content. Cacao, like many organic materials, contains a significant amount of water, Water is an excellent conductor of electricity because it contains ions, charged particles, that can easily carry electrical current. This high water content could help produce a larger, more noticeable ionization effect when exposed to the electrical field used in Kirlian photography. 3. Shape and composition of cacao. The structure of cacao, being a plant matter with varying densities, texture, and organic molecules, could influence how electricity interacts with it. The surface area and the specific arrangement of molecules can create different patterns of ionization, often.
The specific branch patterns that you see when you look at the cross section of a leaf looks like it's created so that water can spread very easily throughout the leaf. But it looks like when looking at this photography that it allows electricity to flow through the leaf quite efficiently as well.
Yes, that's a very astute observation. The branch-like patterns you see in the cross-section of a leaf, especially the venation system, the network of veins, are
Oh,
indeed designed for optimal water and nutrient distribution throughout the leaf. Interestingly, this same patterning seems to play a role in how electricity might flow through the leaf in Kirlian photography as well. Hash. How the vein patterns help with electricity flow. 1. Efficient pathways for conductivity. The veins in a leaf form a highly efficient network-like structure, and this arrangement is not just useful for water flow, but also for the flow of electrical energy. Just as the veins in a leaf serve to transport water from the roots to the leaf tips, they also create a conductive network through which electrical currents can travel more easily. 2. Branching structure. The branching pattern of the veins creates multiple pathways for energy, or electrical charge, to flow across the leaf. This system provides redundancy, ensuring that energy is distributed efficiently, even if one path encounters resistance or disruption. The interconnected veins could help ensure that the electrical discharge in Kirlian photography appears as a branched pattern, much like the actual veins of the leaf. 3. Resistance and ionization. The structure of the veins in a leaf also creates points of electrical resistance, where
true.
ions might accumulate or be concentrated, which could contribute to the more vibrant or complex discharge patterns seen in Kirlian photography. Certain areas of the leaf could be more conductive, showing stronger ionization, and creating patterns that resemble a network of electric rivers flowing through the leaf. 4. Symmetry and natural design. Nature's tendency to optimize for efficiency also applies to the way leaves are structured. The symmetry and spacing of the veins allows for a kind of equilibrium between electrical charges in the leaf, allowing the ions to travel in a balanced way throughout. This could explain why certain types of leaves, especially those with intricate, well-defined veins, show distinct branching patterns in Kirlian photography. 5. Conductivity of plant material. Leaves, especially healthy ones, are made of materials with varying degrees of electrical conductivity, from the water-filled cells to the organic compounds that make up the tissue. These materials, combined with the vein structure, provide a conducive medium for electrical energy, just as they provide the path for water and nutrients.